Hello students, as we have discussed in the previous video, how to name a coordination compound. In this video, we are going to discuss how to make a formula for a coordination compound when the IUPAC name of that coordination compound is given to us. So, we'll be taking a textbook question here in order to discuss such type of questions. So, let us do that question. It is an in-text question, that is, the question is write the formulas for the following coordination compounds. Here you can see the name of the coordination compound is given to us, that is IUPAC name. We need to make the formula for this compound. So there are certain rules that we have already discussed in the audio session. So let us do this one by one. The first one is tetraamine diaqua cobalt 3 chloride. So first of all, we'll be writing the symbols for the element which is given, as we know that after the square brackets. First we'll start with the central metal ion. So we need to write the central metal ion first, that is cobalt symbol you need to write. Then the ligands. Ligands here, amine is the ligand, tetraamine. So we have to write NH3 4 times. And diaqua water. Aqua means water. So we have to write H2O 2 times. Why? Because diaqua is given and it is ending with the counter ion chloride. So that will be writing Cl here. But how much number of Cl it is not mentioned in the question. That is, in the name it is not mentioned how much of chloride ion is present as a counter here. That is, this 3 is not known to us. So how we finding out that 3 that we need to discuss here. So this is already the answer is given to you. So let us, our aim is to find out the X here. What is X here? This is unknown to us. That is, the number of Cl, that is chloride ion, is, we have to find it out. That I'm keeping as X. Here the oxidation state of the central metal ion that is given, that is +3. How it is +3? Because in the Roman letters it is given 3. So that is +3 is the oxidation state of central metal ion. What is the oxidation state of water? That is 0, because it is a neutral ligand. And ammonia, that is also a neutral ligand. So its oxidation state is 0. And what is the oxidation state for chloride? That is -1. But how much of Cl are there, that we have to find it out. So we'll be doing the calculation here. How? So +3 is the charge on the central metal ion, plus 0 is the charge on water. So 0 plus, then 0 is the charge on that is the oxidation state here, that is the ammonia, 0, plus here X number of Cl are there. So -1 into X, that is -X, that is equal to 0. So we have to say that is equal to 0. When you solve this one, so we'll be getting +3 minus X equal to 0. So what will be the X? That is 3 is equal to X. So what we got the value? X is equal to 3. That means here the chloride which is present as an counter ion here. So we have identified that how much of Cl are there. We have 3 Cl. That is the answer. It is given 3 Cl here. So in this way we will make the formula. Next one, potassium tetracyanonickelate 2. Here it is given potassium tetra, that is, it is having a counter ion, that is K. So how we, first of all, we have to give the correct symbol here. So better we'll start with the potassium here, because the potassium is the counter ion. So we'll be writing potassium, the symbol is written, but we don't know it is 2. So that will be finding out later on. So next is nickelate 2, because it is an anionic complex. That's why it is given nickelate. So symbol for nickelate, Ni, and the oxidation state is given in the Roman letters. Tetracyano, cyano symbol is Cn, and because it is tetra, so we have to 4 times of this. So this is what you are making first the rough idea. In this we are not knowing this term, that is K, how much of times the K ion is there, that is K plus ion, that we don't know. So we have to find out, our intention is to find out how much of K plus ion is there in this complex. So we are keeping the number of K plus ion as X. So we are keeping this as X. Now find out the oxidation state for each here, because K know that the potassium always it have one positive charge. So we'll be keeping one positive charge on this one. Nickel it is given the oxidation state 2, that is in the Roman letters it is given, so it is +2. Then cyano we know that -1 is the oxidation, that is a charge. -1 is the charge for the cyano, and 4 times it is given. So let us make what is the overall charge of this molecule, because the overall charge is 0 here. So that is overall charge is equal to 0. So how we do the calculation? Plus first potassium, that is +1 is the charge for potassium ion, and because X times of potassium ion is there, so we'll say +1, that is 1 into X is equal to X. Next plus nickel having +2 oxidation state as given in the name, so it is written +2. Then we have cyano -1 is the charge on the individual cyano, but 4 times are there, so -1 into 4, that is -4. So -4 is equal to 0. Now when you solve this one, what will be getting? That is X minus 2 is equal to 0. Why we are keeping 0? Because the overall charge of this molecule is 0. Because when you consider the counter ion with this complex, the overall charge is 0. Now when you solve this one, you will be getting X is equal to 2. So what we got? X is equal to 2. That means our counter ion, that is K. K is now, it is known to us. What is the X? That is X is what? 2. 2 is the X, we find it out. So that is what the answer is 2 here. So K2. Why it is 2? Because we have find it out just now. So this is the formula for this complex. Now the next one, that is the third one. It is given name tris ethane 1,2-diamine, that is ethylene diamine, chromium 3 chloride. So first of all, we'll be starting because it is ending with chloride. That means it have a counter ion Cl here. So first we'll start the bracket. We'll be keeping the bracket sign, square bracket, and we'll starting with the central metal ion. Which one is the central metal ion? That is chromium. So we'll be writing the symbol for chromium Cr. Oxidation state is given, so that will be using. And here En, that is ethylene diamine, in short, that is ethane 1,2-diamine, which can also be called as ethylene diamine. In short, we'll be writing En. Instead of writing the whole formula for this, we'll be writing En in short. And tris word is used. Tris word is used, that means it is of 3 times. So 3 we are keeping En 3 times, and then it is ending with the counter ion chloride. But how much of chloride ion, that is not specified in the name. So our aim is to find out the number of chloride ion, that we have to find it out. That is whether it is 3 or not, that we have to confirm. So we will be keeping that's just, we don't know what is Cl here, how much number of Cls are there. So let keep this as X. So now let this is X for us. So we are aim is to find out the X here. So as already given in the, this is an answer that is already given 3 here. So how it comes 3, that we are finding out here. So first of all, write the individual oxidation state. Cr, chromium, that is 3 is given in the Roman letters. So we'll be writing 3 here. Because En is a neutral ligand. that means it does not have the charge. So I'm keeping 0 for En, and Cl we know that chloride have -1. The single chloride ion have -1 charge. But how much of Cl are there, that we have to find it out here. What is the overall charge of this molecule is 0. Including the counter ion, we can say the overall charge is 0. So just now solve it. What is the oxidation state for chromium? That is +3 plus 0 into 3, that is 0. En is 0, neutral ligand. Then we have chloride. So here x number of Cl we have taken, that is -1 into x, that is -x is equal to 0. Because the overall charge of this molecule is 0, that's why we are keeping equal to 0. Now when you solve this one, that is 3 minus x equal to 0, that is 3 is equal to x. So what we are getting here, x is equal to 3. That means the number of chloride ion, that is 3. That is what it is written 3 here. So this is the formula for this compound, that is tris ethane 1,2-diamine chromium 3 chloride. Next one, the fourth one, amine bromido chlorido nitrito and platinate 2. In this, because there are number of ligands are present, and here there is no counter ion. When you look at the name here, there is no counter ion. That means it should be having some charge on the complex, that is in the coordination sphere there should be some charge. As first of all we write the symbols for the ligands and the central metal ion. Here which one is the central metal ion? That is platinate. It is given in the name, that means Pt. We have to use the symbol Pt. Platinate it given, that means it should be a anionic complex. Next, amine word is used, that is a ligand amine, that is a symbol NH3, because here no prefix is given, that it shows that it must be single NH3. Next, bromido, the symbol is Br. Here also no prefix. Dibromido, tribromido, that is not given. It is only given bromido, that means it is single Br. Similarly, we have chlorido. We will be writing the symbol Cl. Then nitrito N, that is the symbol NO2. That is other ligand. So here 4 type of ligands are there, that is amine, bromido, chlorido and nitrito N. So we have given the symbols for these each. Now what is our aim? Because the oxidation state of central metal ion is given to us, but our aim is to find out the charge, that we are keeping as x here. As we don't know what is the charge on this, because this negative is already written, that is the answer. But how we have come up with that, we need to find it out. So that I am keeping as x here. So what is x? X is the overall charge on that complex ion, that we have to find it out. Here the central metal ion, it is given in the Roman letter. The oxidation state, that is 2. So we are keeping it is +2 here. Next, ammonia is a neutral ligand. So 0 is the oxidation state. Br have -1 oxidation. Cr have, chlorine have -1, and nitro also have -1. Now we'll be making the sum of this one, because the overall charge here, that we have kept x here. So we'll be writing like this. So +2 is the oxidation state of Pt. Then ammonia oxidation state, that is a neutral, therefore 0. Then Br, it is -1. Then next chlorido, that is -1. Then nitrito N, that is nitro, it also have -1. So that is all is equal to, this is -1. That is all is equal to the x charge. What is the x charge? That is the overall charge. So when you solve this one, we'll be getting 2, then -1, -1, that is equal to -3 is equal to x. So what is x here? -1 is equal to x. So what we got from here, that is the charge on the complex that is on the coordination sphere the charge is -1. That's why we got a -1 here. So that is the answer. How we come up with this -1? By keeping the x first this, and we have solved it. So like this we have to do the problems. Now the fifth one, dichlorido bis ethane 1,2-diamine platinum 4 nitrate. Here nitrate, it is ending with nitrate, that means the counter ion is NO3. But how much of NO3 it is not written in the name, that means it is X times. So we don't know how much of nitrate is that we have to keep X. Here the other symbols we have to write here, that is platinum, that is we are writing with PET. Then dichlorido means Cl2. Then it is given bis ethane 1,2-diamine. Bis word is related, means En is 2 times. Then nitrate, the counter ion is nitrate, but how much of nitrate it is not specified, so better we'll keep X here. That is, what is X here? That is the number of nitrate ion we'll be keeping at as X. That we have to find it out. So first we'll starting with writing the oxidation state for each. Platinum, it is given 4, as in the Roman letter it is given 4, so plus 4. Then chloride, it is -1 for the individual. For En it is 0, and we know that for nitrate it is -1. Nitrate ion, what is the charge? -1. Now we'll be making the sum of these charges, because the overall charge of this molecule is 0. Why? Because there is no overall charge on this, including the counter ion. We can say that there is no overall charge, that is equal to 0. So first we'll be making the sum of the charges, that is plus 4 is the oxidation state for PET. Then we have a chloride, because here -1 is the individual charge and 2 times it is there. Therefore -1 into 2, that is equal to -2. Next we have En. En is equal to, what is the charge? Neutral, therefore it is 0. Then -1 is the charge on nitrate, and X number of nitrates we have kept. Therefore -1 into X, that is -X, that is equal to 0. That is, the overall charge is equal to 0 for this molecule. So when you solve this one, what will be getting? That is 4 minus 2 minus X is equal to 0. So that is 2 minus X equal to 0. Therefore, what will be the X? That is 2 is equal to, that is X is equal to 2. So what we got from this one? That is X is equal to 2. That means the X, what is X? That is the nitrate ion. How many number of nitrate ion is there? That is X is equal to 2 we got. So that is what we got 2 here. So why it is written 2? Because we have find it out by keeping the X, that, and we have solved it. So we got X is equal to 2. So this is the formula for this complex. The sixth part, that is iron 3 hexacyanoferrate 2. How we make a formula for this one? It is one of the important one, because 2 to 3 times this was asked in the board examination. So let us do how to make this formula. So first of all, in this the 2 here iron 3 is also given, iron ferrate 2 is also given. That means here this is actually the counter ion, and this ferrate which is representing, that is a central metal ion. And because iron can form variable oxidation state, like it can form +2 and +3. So the oxidation state of iron is given here, that is +3. That is the oxidation state of counter ion. So that counter ion is represented here, that is iron is represented by the symbol Fe, and we have a oxidation state +3. But this ferrate is representing the central metal ion, and its oxidation state is +2. Hexacyano is relating with the Cn6. How we write cyano? Cn, and hexa 6. In this example, the number of a counter ion is not specified in the name. Therefore, how we got 4 here and how we got 3 here, that actually we are discussing here. So this is actually the answer for this. That is the formula for this IUPAC name which is given here. So how we got 4 and 3 here, that we need to discuss. So better we keep this one as X, that is number of counter ion will be keeping as X, and the oxidation state here for ion, that is given in the question 3. So that is plus 3 is the oxidation state of ion, that is a counter ion here. And what about the oxidation state of the central metal ion, that is also Fe, that is actually plus 2. And what about Cn? We know that it individual oxidation state, that is the charge, it's minus 1, and it is 6 times it is given in the question. So when we make the overall charge here, it is equal to 0. Therefore we can write plus 3 into X, that is 3X, that is for ion. Then plus central metal ion have 2 charge, therefore plus 2. Then plus, what about the sign Cn? Cn have minus 1 charge for the single Cn, and 6 Cn are there, therefore we have to multiply 6 into minus 1, that is minus 6, and that is equal to 0. The overall charge for this is 0. When you solve this one, we will be getting 3x, that is minus 4 is equal to 0. That is 3x is equal to 4. What will be the x? X is equal to 4 by 3. So here we got x is equal to 4 by 3. That means what is the x? X we have taken the number of the counter ion Fe. So how we write down formula? We'll be writing Fe 4 by 3. Fe 4 by 3, and this is not mentioned. Now how we can remove this, how we can take it into the normal form, like remove the fractions. How we can remove the fraction? Because here at the denominator we have 3 times. So multiply this whole with 3 times. So when you multiply this whole with 3 times, we'll be getting, that is Fe thrice Fe, and this thrice will get cancelled. So that is Fe4. And the rest of the part, this all will have now 3 into this. So that is actually written here in the bracket. So this we have written here. So why we got 3 here? Because we are multiplying 3 to overall this. So we are getting 3 here in the coordination sphere. So that is what we got the answer here, 4 and 3 in this example. So this is a little bit different from the other examples. So it is done in this way. So we have discussed about some of the questions, that is the IUPAC name is given. We made the formula for that complex. So this is all about this video. Have a nice day.